Okay, you can go ahead.
All right, thanks. Good afternoon, everyone. So I'm gonna give an overview of complementary software platforms that we have been building for a while on the top of OpenAirInterface to enable a more use case driven validation. So let me start just highlighting this session organization. So I'm gonna start presenting the Mosaic 5G projects, the status and the roadmap. Gives you an overall picture of what Mosaic 5G is doing and how it is related to OAI. You saw it before in Florian's presentation. I also complement that. Then there will be a presentation on orchestrator platform that we have been building, Kube5G, done by Osama Arouk, and some hands-on. So it shows you how you can deploy different blueprints. The demonstration will rather focus at this stage on the 4G. The same also is valid on 5G. And Robert is going to give you an overview of FlexRAN and some hands-on. So what is Mosaic 5G? So the Mosaic 5G, it's a service platform as opposed to OAI, which is infrastructure platform for 4G and 5G. So here we try to give some service flavor to OAI and a set of use cases. So the way we look at the problem is more which use case we could enable, which use case we could experiment, and what are the needs on the top of OAI or any 4G or 5G platform to actually make the 4G and 5G a service platform. So this initiative actually also founded by Eurecom and launched in 2016. And now all the code base, also the governance has been transferred to Software Alliance. So this is something we announced in our previous workshop. All right. So I want to here go a little bit in comparing, but very high level, right? It's not a technical deep down comparison, but more from the high level perspective, the difference between 4G and 5G. So one of the design patterns of the 4G was that it was communication oriented. We wanted to have a very efficient high performance transport channels, like the data rate was very important. It was designed bottom up, like we really wanted to have a very good design of the physical layer and also the stack to enable a high data rate, mainly in the downlink. And it was like a one size fit also. The perspective for release 8, which was 2008, was for one network for all use cases. So the design was targeting high throughput scenarios, and they were not seeing back in 2008, let's say the scenarios where you have a high density, the scenarios where you need a low latency or high reliability. Then in 5G, the IMT noticed that, okay, we are going to have a lot of services and human-oriented communications is not that important. It's not be the driving forces of 5G. The driving forces of 5G would be verticals, the long tail. So that's why 5G started to be service-oriented, and the whole design pattern was top-down. So how we could enable use cases, how we could use the 5G network in the factory, in the car, in the city, and for the human as well. And this also brought up the idea of multiple virtual network on the top of the same infrastructure. So you kind of dimension networks, you create some virtual network, and we are talking here about the mobile network. Multiple virtual network, each configured for different services, and there are certain level of isolation and performance guarantee for each of those services. So 5G also leverage a lot of IT technology enablers, like for instance, you're already completely aware that SDN come in the wired, like Open Daylight, like POX, NOx for switches, open flow switches. It got into 4G and 5G, NFV and cloud native computing. So you see the impact that Kubernetes brought into mobile network, the impact that let's say an HCNFV, a working group, brought into a mobile network. Multi-access edge computing, so to improve the latency and the reliability, to bring some high performance local clouds very close to the base station, and finally anything related to the data-driven approach with enabled by machine learning and AI. So this is the leveraging all the IT technologies into telco domain, very important. And then rapid cloud-ready prototyping and innovation. So you want to have some rapid prototyping of these technologies on the top of the mobile network, and of course experimenting use case. So this is how this Mosaic 5G initiative started, with this idea in mind. So the objective is very clear. 3GPP technologies in general, so 4G, we started with 4G, and now we try to move into 5G. Commoditization using x86 architecture as opposed to hardware accelerator, as opposed to dedicated hardware platform. Softwareization, which is also the objective of OpenAir 2. Cloudification, so cloud-ready solution, so running on the container, whether at the host level or at the application level. Data-driven, to bring intelligence into the picture, and openness. Openness in terms of rich set of APIs where we could develop X apps and drive the network with our fancy algorithms and validate those algorithms on a real network as opposed to the simulator. So here is the stack of Mosaic 5G. On the bottom, the blue, you see OAI, as you saw before. This is where all the OAI code base for 4G and 5G resides. In Mosaic 5G project, we kind of created a software packages for OAI. So instead of you going and doing git clone of the repository, so Robert showed you the steps. Instead of going to get the source, compile and run, you have a software packages. You have a software packages. You can get the software package already built, and you run on your system without getting from the source, without compiling. Then we have two platforms, two controllers. One obviously is the RAN controller, the other is a core controller that is combined with the multi-access edge computing with the limited features though. So the FlexRAN is quite a well-known and well-used platform providing software-defined radio access network. So this is a platform that shows you how we applied SDN, software-defined networking, into the RAN. And Robert is going to give you more in-depth look into this platform. LLMEC, low latency multi-access edge computing. So this is a platform that provides you traffic control, like you can manage the user traffic to redirect the user traffic into the local or edge services. So some services, some users are served in the local edge or multi-access edge platform, and some others they get served by the backend. This is also acts as a core network controller. Then we have a store. So this is the idea is having a network store similar to the app stores that we have for the device for Android and iOS, whereby we have a set of software development kit on the top of the northbound APIs of FlexRAN and NLMake, where you can build some monitoring apps so to get the data from FlexRAN using the REST API of FlexRAN, using LLMake REST API to get some monitoring on the core, combine it and make some decisions or observe some behavior, some trend, and so forth. So you could have some monitoring apps, some control apps. For instance, one simple use case you can experiment is about the handover, like handovering, network triggered handover of users from one cell to another. And then finally, the orchestration platform. So there are two flavors. One is JOX that we stop the development, which is Ubuntu. We are using Ubuntu tool, Juju. So it's a Juju-based orchestrator. It is only today supporting 4G. And there is a new one, Kube5G, which operates on the top of Kubernetes and OpenShift operator framework. So here you have different blueprints. You can define the blueprints and deploy your network with almost zero conf and zero touch. So Osama is going to give you a deep overview of Kube5G with also some hands-on. In case you are interested, you can also use this tool to deploy OAI and then use it for your research and your experimentation. I don't go through the license, but if you are interested in the license, you have some details below in terms of how things are licensed together. So FlexRAN, so I don't want to explain you too much because I'm sure Robert is going to give you a good overview on that, but on the figure on the right-hand side, you see the let's say conceptual, but also to certain extent software architecture of FlexRAN. So on the bottom, the blue is OAI. This OAI is abstracted through a certain southbound API. We call it RAN API. On the top, we have a green RAN runtime. It's like an agent that talks to the master controller on the top. So between them, there is this FlexRAN control protocol. So through this FlexRAN controller, real-time controller, the application on the top, they can exercise some operation. They could monitor. So they ask, give me the data of the RAN right now. This will translate from a northbound REST API into the FlexRAN protocol, comes to the RAN agent RAN runtime, use the RAN API to get the data and send it back to the control app. Actually, as a matter of fact, this status and monitoring are more periodic. So when you request, the real-time controller already has the answer. But for some other operation, you may need to go to the control protocol and get the result and present it to the control apps. Yeah, you see here that at some point the RAN user plane is connected to the S1 interface. So this is only showing the 4G. We need to update the slides, but it's connected to the core network. And on the other side, it could be directly the air interface, or in case of disaggregated RAN, it connects to, let's say, DU or RU, the other modules of the RAN node. So this controller is, we call it real time because it's in sync with the underlying base station. So if we go through the list, so we have these plug and play X apps. So all of these apps here, they can be plug and play on runtime. There is this real-time controller, which is a centralized controller controlling multiple base stations, abstracting the E node B or UE stats and the resources. And we have the agent runtime, which is here, which provides, which acts as a local controller, provides certain level of abstraction and programmability of the RAN network function. And then finally, this FlexRAN protocol that we see in between is where we communicate with the RAN user plane about the statistics, configuration, commands, events, and control delegations. So currently, if I want to be more concrete, what is available in FlexRAN in terms of implementation, what you can do, on the left-hand side, you can get the states, so monitoring. You have a network store, so you can get some applications from the network store and push it into the base station. You have a monitoring, so you can get the data from the RAN and push it into Elasticsearch, for instance, database, data store, or you can record the data and then use it for some offline processing. You have a PLMN management, like demonstrating the multiple operator core network, network slicing, and so forth. RRC control for the mobility management, cell configuration for spectrum management, like you change the frequency and bandwidth, and slice configuration. So to create network slices, allocate some resources and some performance. So with this, all of this, you can realize a certain number of use cases like RAN aware video optimization, like you read the status, you measure the link quality in uplink and downlink, and you inform your video server the optimal transcoding to set in uplink or downlink. This is just one example. You have many more. LLMake, as I said, is the counterpart of FlexRAN.
I have one question.
Sure.
Can you, you have mentioned here centralized coordinated scheduling. So can I also put some algorithm which will be updated per TTI? Is that functionality available?
Could you elaborate what kind of algorithm, like for scheduling, you mean?
Yes.
Okay.
At central entity for a number of e-node base in a multi-cell network.
Right. For the coordinated scheduling, one thing that is possible today is more about the policy you can enforce, right? You cannot currently, in the first version of the FlexRAN, this was possible that you can actually do the per TTI scheduling. Your objective is to per TTI scheduling.
Yes.
Yeah. In the current version, the per TTI scheduling is not possible. However, through the network store that you see here, if you have a scheduling that you want to develop, you can push this into the logic of the base station. This is feasible. The only thing here at this stage you can do, and you can increase the frequency of where you push the policy, you could use that policy enforcement to be as close as possible to the scheduling. But per TTI scheduling in the latest version is not supported. But you can get the original version. In the original version, this was supported. I think Robert could, in the part of FlexRAN, could cover more on this coordinated scheduling. All right?
Okay, thank you so much.
So LLMake is the counterpart of the FlexRAN, but for the core network, it provides the user plane packet redirection based on the policy. So you have default services that go, let's say, to backend to the internet, and edge services, and this has the possibility to redirect the traffic to the edge services. And of course, through the controller, you have some make applications that gets the status and operate on different users, different applications. So we have in LLMAC platform, we have two modules, two important modules. One is edge packet service, which is act as a traffic rule control, and it is realized using OVS, Open Virtual Switch, with the GTP. And we have radio network information service, which is realized through FlexRAN, so where we get all the information. And then there are a number of, let's say, REST API and an SDK on the top. So implemented use case, again, this video optimization I showed you is a combination of FlexRAN to measure the data rate on the radio, on LLMAC to redirect the traffic to the local video optimizer, right? So they work together to realize, for instance, this video optimization use case. Traffic steering, this is where you redirect the traffic based on the service and the user. Network slicing, dedicated core network, so you can actually have different core networks for different services. This is also enabled on the FlexRAN. You saw the APIs for the PLMN management and so forth. So this, for instance, service offloading through the traffic redirection, you can offload a part of the service into some local edge servers. This kind of exemplify a use case or a deployment using FlexRAN and LLMAC. So you have some UPF, which could be like open virtual switches that supports GTP. On the left, you have the base station that RAN agent, RAN runtime operates with the FlexRAN. LLMAC and FlexRAN, they talk to each other to, let's say, get the radio status. And LLMAC at the same time talks to the core network. And then you have this traffic of different users from the UPF OVS functions. Instead of going to the remote application server on the back end, they are redirected to some local edge servers to, of course, improve the latency, for instance, or improve the service performance. Kube5G, this one is the latest software we developed. The objective is to provide a cloud-native 5G service platform leveraging Kubernetes and container technology, Docker or Podman or others. So it has open APIs. It supports Snap, which is the Ubuntu packages, SDK, and the container. So different technologies are used. But from the user perspective, this is highly integrated. You don't see all of those details, but behind the scene, there are a number of technologies that have been used. We use OpenShift operator for RAN, core, and FlexRAN to facilitate the deployment, reconfiguration, and also in general autopilot. Osama will cover that more. And we also have a set of life cycle that is supported in terms of deployment and release, upgrade and reconfiguration. So today, this tool at the current stage, it does not support machine learning or AI, but you see here the extension Osama will cover. There is a new tool that is coming, which is called Kubeflow, which is actually used for machine learning and AI, and this is something we are looking into to actually do some extension for people using this tool to perform more advanced processing of the data, to implement the data-driven action network. So toward the end, I try to keep in time. So the store is another piece of Mosaic 5G project. Here we are talking more about the cloud images, data sets, API, use cases, and component. So X apps, for instance, the application on the top of FlexRAN and LLMake are considered as a component that are running, and they are reusable. So you can reuse them across different scenarios. They are reusable, they can be extended. So you could take the X app, extend it, add some functionalities, you can plug and play, and they can also be containerized or cloudified if that is required in the use case. So as I said, components we have Snap packages, Docker Cloud images that are available. We have open APIs, so some APIs that are available for experimenter to use, and some charms and blueprints. We have the software development kits. There is 4G, 5G service platforms. That is basically the combination of infrastructure being OAI together with FlexRAN and LLMake, and some data sets that you have a lot of possibilities to extract data from this platform, whether it is L2 SIM or real RF. In terms of the roadmap, today we are actually in release 2.0. So a bunch of, let's say, platforms are published and available for usage. And what we are heading, we're really heading for intelligent. So now a bunch of, let's say, service platforms have been developed. They are going to be extended for sure for the 5G. What we are looking is more like a holistic monitoring framework that enables advanced AI and machine learning. Okay, in conclusion, so many use cases are becoming possible with OAI and M5G, ranging from complete telecom to service applications using open source, right? Very important. All of these tools now are cloud ready under Ubuntu and CentOS, so they are also easily portable to other distribution. So it is possible today to experiment many ideas. Of course, you need some expertise in programming, in networking, in scripting. And if you have those, then a lot of possibilities become open to you. So you can compose and customize the network service, you can automate the deployment, you can develop X apps, handover, I gave the example, coordinated scheduling. This will come, but for instance, for the policy enforcement, you can develop X apps on the top and deploy it and then measure the performance from the end-to-end user perspective. This is possible. You can do a slicing in today's FlexRAN, create some slice, allocate some resources, and measure the performance of the slice and how the slice are competing with each other. Very important. Complementary material. So what I can recommend is that in December last year, we organized a workshop, and in that workshop, we had a complete set of training of each platform with a dedicated slides. So this link is important if you want to get access to it's open, there is no registration. You just go to this link on our website, and then you get the PowerPoint the PowerPoint presentation, link to the YouTube for the video, and probably some other materials, for instance, the scripts and so forth. And here the YouTube is the YouTube channel where you can watch some videos, again, tutorials in how to set up the platform. I think with this, I end, and I think I'm on time. So if you have any questions, I'm available. Otherwise, I think we can move to the Kube5G. Osama will be presenting that to you.
You mentioned about AI and ML platform as a Qflow. So, is it will you make some ML algorithms available at OAI platform, or will it be some basic infrastructure available to implement any other ML or AI
Okay.
algorithm by other users?
I will give a little answer, and then I let Osama to answer completely. Our
Hello. We cannot. I cannot hear anyone.
I was ejected from the call. I don't know why.
Okay.
Anyway.
It was my mistake. Rabbitis Christos.
Yes. So
But I
the
can see
short
someone else.
What?
Okay, go ahead. I can see an external people here that I don't want him in the meeting.
The next speaker will be Osama Arouk.
Go to Sama. Okay, let me remove Sama from the meeting.
So to give you the short answer, the first objective is to connect the Kube5G to Kubeflow, so that everyone could actually implement their own machine learning or AI algorithm. So at the beginning, we are not going to propose any algorithm. We just connect it to the right tool so that you can use it to perform some learning. And then at the next later stage, we will be working on some X apps that are developing some ML algorithms.
Okay, and is this already in your timeline, or when will it be available?
Maybe I let Osama to say normally we would like to add this quite soon, maybe a couple of months, huh? Not right away, because the tool, the Kubeflow, is also getting evolved, but it's not going to be let's say more than a few months. I let Osama to give some timelines if he has.
Okay. I will. Sorry, I will introduce you Kube5G, and after that I will give some information about Kubeflow and what could be the next.
Okay, it will be very interesting to know when will it be available. At least the connection of Q5G to Qflow with
Yes.
the platform. It's
Actually, I have one figure that it shows this connection, so it will be like interesting, I think, for you.
Okay, thank you.
Bruno, I can start from my side, sharing my screen.
Yeah, I'm not. I still don't see your screen, but I'm not managing this the call. I'm just.
I cannot see this possibility. Okay, and I think it should be this one, screen 2 maybe. hope that you can see my presentation.
Yeah.
Okay. Okay. Kube5G. In a nutshell, Kube5G is agile 5G service platforms. It's composed of 4 main entities, like regarding the cloud-native telco domain. Kube5G, it is a realizable agile service platforms for telco domain for 5G and for 4G and 5G support. In terms of the design of network, cloud-native network functions, the design that we provided in Kube5G, it is a nested layer design with a realizable loosely coupled layers. So like you can imagine that we have multiple layers. If you have like some improvement or some new features in a certain layer, you can they can have like completely independent life cycle. So you don't need to update everything. You can update only what has new features. What is the important also, like this design, it conforms with the CNCF principles for telco domain and 12-factor methodology for designing software as a service. In terms of the DevOps, Kube5G already support the CI/CD for the fast release for the new features or new functionalities. Additionally, Kube5G support multi-version for the physical, virtual, or cloud-native functions. And finally, to make Kube5G extensible and to be like adapted for new functionalities that may be needed in the future, we provide a set of extensions. Currently, we have a Kube5G operator for the automation of the deployment and orchestration in Kubernetes. The second one, Kubeflow, which is kind of like partially ready, but it needs some time to be like completely ready for the public. And also we plan to support Prometheus or Elasticsearch for the monitoring and logging. What is supported now for the moment in Kube5G? In Kube5G, you can deploy 4G networks in less than a minute, where I will show you an example. It is very simple and very easy using, for example, Docker Compose. Additionally, Kube5G support the shared or dedicated resources, where this feature, it is kind of like exploited directly from the Kubernetes, where like you can define whether certain function or certain service needs like dedicated resources or it can be shared. Additionally, Kube5G provide a fine-grained end-to-end service control and monitoring using OpenAPI, which is mainly for the snaps, as Navid presented the snaps. And also we have like agile continuous development and deployment using Jenkins for the fast and release of new features of the functions. What is also possible that we can do flexible functional split, that is kind of like straightforward, that can be supported. Support multiple PLMs, so you can imagine like create multiple networks with multiple PLMN, and you can deploy it easily using Kube5G. Additionally, we provide customized core network. So you can imagine you need like to deploy only the RAN part, but you already have the core network. So you can, from the configuration, you specify that this RAN that need to connect to a certain core or multiple core, which is already feasible and already supported. And finally, with the set of extensions of X apps that already exist in the store, that you can do many interesting things like performance monitoring, PLM management, or even SL configuration. The three main components in Kube5G. What is very important in Kube5G, that it is compatible with the CNCF, that is leading the cloud native deployment for telco domain, which is a very huge community. The additional important feature in Kube5G, again, it is for the 12-factor methodology support. It is a well-known methodology to design software as a service. The second main feature in Kube5G, it is Agile and telecom friendly, where Kube5G provide different deployments or different deployment regarding the aggregation or disaggregation, where I will show you many examples about this deployment. And if you would like to control your network, like for example, get the statistics from the Rampart or control the core network using LLMIC, it's also straightforward in Kube5G. What is very important for you as a user is that it is Kube5G, it is easy to build, where it is we provided already like a script that you can build a Kube5G, and also very easy to reconfigure, where we provided only one config file that you need just like to maybe change just very few parameters according to your setup, and after that you can go ahead and directly use a Kube5G operator or Kube5G and Docker Compose. The three main components in Kube5G are as follows. Firstly, we need Docker for the automating the installation and the configuration of the containerized applications, where here we build the Docker image for all the OpenAirInterface entities like the RAN and for the core network, for the FlexRAN and all the other entities in 4G and 5G networks. And also it provides an easy to use with a zero-touch configuration for the deployment in one machine. The second and the more important component is Kube5G operator. As I said before, the objective is to automate the deployment for 4G and 5G network in cloud-native environment, as a Kubernetes, where it can auto-configure or reconfigure, update, or upgrade the network for you according to your need or according to the current traffic in your network. And more importantly, you can define that your need about the aggregation mode that you needed, again according to the current traffic in the network or the current user traffic. And the final component, which is very important also, it is the CI/CD to automate the full life cycle for both VNF and CNF. In such a way, we can provide new features or new functionalities to the end user in a quick and a reliable way. Where here, like we provide the whole pipeline, where the first stage to get the source code, for example, from GitLab, and build the VNF, which is snap for our case, and after that go and test it in a unary test to make sure that all the new functionalities doesn't bring the current functionalities that already exist in the for the function. And after that we go to the next step, which is building the CNF, which is for the moment we support Docker, but we're already working about supporting different container engine like Podman or Containerd or many other container engine. And the next step is like to go and test the CNF in deployment case for deployment scenario, and if everything is fine, we go and test it or deploy it in a production environment, which is Kubernetes for our case. What is Kube5G? As Kube5G from the point of view as a software architecture, it is composed of the from the bottom to top. Firstly, we have the infrastructure, which could be any type of infrastructure, bare metal, virtual machine, or any cloud. On the top of it, you have Kubernetes running. So there are like different types of deployment. Maybe some of you know that you can deploy Kubernetes in one machine, like for example MicroKS or Minikube, or you can deploy it on multiple machines using Kube5G. On the top of it, we need the Docker or a container engine. And for the case that your application cannot be containerized as a CNF application, also there is like different container runtime engine that is needed, which could be like Kubevirt or Virtlet. On the top of it, you have your function is running, where, for example, here we support OpenAirInterface, as we said before, and all the functionalities of Mosaic 5G. And finally, on the top, we have the OpenAPI, which is very important in the terms of the 12-factor methodology for the objective of communication of the functions among themselves. Also, you can access to the function from outside the world. For example, you have your Kubernetes clusters working, but you need to access it from outside of your cluster, so you can interact with the application through the OpenAPI. And aside, we support many extensions. For the moment, we support the Kube5G operator, and in the very new, in the very near future, could be 1 month, or at most, I think it could be like 2 months, as that Kubeflow that it should be ready and natively supported in Kubeflow. In Kube5G operator. As I said before, the design of CNF function, it is a nested layer design, where the first layer it's composed of the application. Say, for example, the run function that where like we have the run function, for example, and the set of libs and pins that is needed for your function, in addition to the front end. The next step, the next layer, it is the app data, which is important here to separate your function from the app data according to the 12-factor methodology for the ease of scaling. The next layer is utils and hook. Utils, it is nothing more than that the helper tools that you may be needed inside the container, maybe, for example, to do testing, for example, for your function, or any other things that could be helpful for you next to your main function. And the hook, you can imagine it as application managers that manage the life cycle of your application inside the container. And finally, we package everything inside the container, which is, for our case, it is Docker. And after that, your application can interact with many applications through the binding ports, for example, Cassandra as database, OpenAPI, or Kubeflow for machine learning. Regarding the CI/CD process that we supported in Kube5G, in order to make it easy for you to understand, I provided with an example as FlexRAN. So we have the source code, we get it from the GitLab. We start by the first stage, which is a continuous integration for building and testing the VNF function, where we take the source code, we build the snap, which is a VNF function, and after that go and test it using a unitary test. And everything is fine, we go to the next stage, which is continuous delivery, where it is objective to create the CNF and test it in a deployment test scenario. We have, again, similar steps. The first one, create the Docker image, go and deploy it in deployment test, and finally make the tests that you needed to make sure that all the new functionalities or new features that you added to your function, it is still working. It is working, and the already supported feature, it's also still working. And the final stage, which is go and test it or deploy it in a production environment, which is Kubernetes for our case. So again, we have similar steps. The first one is to deploy it in Kubernetes, go and test it in the production environment, and after that, If everything is fine, we go and push the VNF version and the DCNF version to public repositories. Here I give you a practical example to show how the CNF is working. In the first, we have multiple pipelines. In the first pipeline, it is trigger, which can kind of like its objective only to detect if there is any changes that you made it in GitLab. For example, imagine that you make, for example, changes on the FlexRAN and you push it this changes to the GitLab. The pipeline will detect these changes and will go and trigger the next pipeline for building the CNF and test it. And if this stage finishes successfully, it will go and trigger the next pipeline, again, which is for the CNF for building, testing in deployment phase. And finally, if everything is fine, which means if passes from the VNF test and CNF test, which means that our function is ready to be used by the public users. So we push it to the Snapcraft store, which is for the Snap, which is a store for the Snap, and Docker Hub for Docker. Here I provide some already new some of deployment that already supported by Kube5G operator. Like for example, you can deploy your network. I can go from the bottom to top. You can deploy your network all in one. That is, you have one entity as core network, one entity as RAN, and that's connected to the front end where you. And after that, you can connect your phone when the network is ready. And the core network is connected to the database. And also, like there is like the gateway to connect to the internet in the core network. Additional, second, the disaggregation mode that you can deploy it, where like you can, for example, disaggregate only the RAN, where you have like one entity for the core network. So in this case, we have disaggregated RAN and monolithic core network, or you can make disaggregated RAN and disaggregated core network. To sum up, here I provide the Kube5G as the whole picture, so like to link all the entities together. So firstly, the context, the objective is to deploy to support 4G, 5G non-standalone, and 5G also standalone mode in the Kubernetes environment, where the objective to arrive to a zero-touch, multi-vendor, multi-version AI/ML-based deployment, where all these functions will be like released quickly using Agile continuous CI/CD. So here I provide a practical example for the 5G non-standalone mode. You have the database, the core network, and the two base stations. The first one 5G and the second one 4G. After that, we get the statistics from the network, the deployed network. So like using FlexRAN, for example, to get the monitoring information from the RAM bar. And also we get the information about the consumed resources regarding the CPU and memory using Kubernetes or Kubernetes API. And this information will go to the Kubeflow, where you implement your model, where like this, your algorithm will exploit this information for the network and for the infrastructure, take the right decision, and this decision will be communicated to the Kube5G operator, and after that, Kube5G operator will analyze this information that's communicated using your algorithm in Kubeflow to take the right decision what to do, maybe for example scaling one or more entities, or do like placement for also one or more entity from one node to other node. The implementation of Kube5G, so as I said before, we have three main entities. The first one, Docker, or mainly Docker hook. It is kind of like the application manager inside the Docker. It is implemented using Golang. Kube5G operator, it is an OpenShift operator, SDK, where the version is, okay, it's a little old now, it is 0.7, and where also it's implemented using Golang. And the CCI/CD, we use Jenkins for that. The important notice is that all the software release, it's Apache license video, so it's like for free to use it and exploit it for your research. Here I provide a list of useful resources that may be like interesting for you to go and check for the website, for Git, and for a set of Docker image that we already have it. Also, YouTube video, and more importantly, as Navid said, we have like the Mosaic 5G workshop where you can find the slides on the video for that if you would like to know more about Kube5G. Here I provide the live demo, where in this demo I will deploy this simple network that's composed of the database, the core network, the RAN that is connected to the FlexRAN, and you have also the front end that's composed of the USRB and the antenna. So, so the first step that you need to go to the GitLab and get the Kube5G. So if you go here, so all what you need is kind of like just take it and clone it. So here I already clone it. So I have a Kube5G, and we have provided a set of examples using Docker Compose or using Kube5G operator. So firstly, I will show you the Docker Compose. So if I go again, so here this is the Kube5G project. So in order to get the Docker Compose, I go to Docker, Docker Compose. And we have two versions of the Docker Compose, which is like mainly related to the version of the snaps. So for example, if you go to the version 1, LTE, version 1 with the FlexRAN. So this is will deploy this network. So if I say just like Docker Compose up to make the network up in the daemon mode. So Docker PS. So here I have a lot of Dockers because it's also this node, it is linked to the Kubernetes. So if I go in the beginning, I can see my network, it's already deployed. So I have MySQL and I have ZCN, FlexRAN, and OIRAN. And here aside, I have the phone, which is like real phone that it is kind of like connected using application visor. So it is a practical one. So like we just need to wait. So this is USRB that's connected to the machine where I run it this Docker Compose. So just waiting a little of time. Seems to me I forgot to connect the USRB. So this is I need to stop the network to connect it again. So here to do the restriction of the time, so I will show you only the Docker Compose. But if you are more interested, so you can go to the workshop and you have like more details about Docker Compose and the Kube5G operator. Yes, now, so like the USB, you see that like you have the light, so it means like the USB is already connected. So we can just try to connect the phone. So we see here it already have a network LTE. So we can just like quickly check whether we have internet. So you can see it's like really very easy, just like in less than 1 minute you have like your network up and you can connect your phone. So I don't know if you have any questions. Sorry to be like to take a lot of time. So if you have any questions, you are welcome. Hello, can you hear me?
Yes.
So I don't know if you have any question.
From my side, no.
Okay, thank you.
Hello.
Hello.
For like there is some network instance for management, like for network slicing, we have to manage this. So OSM, can we integrate in this picture? OSM open source manner for network slicing purpose. Actually, I'm asking.
Actually,
Like here you use Kubernetes for management, right? Orchestration management.
Kubernetes, okay, here I use Kubernetes like for the deployment. So like this is kind of like orchestrate. Kube5G operator, it will be automate the deployment. So like here.
So actually, I have question: is there any plan to use open source manner for management purpose or orchestration purpose?
Actually, for the moment, no, we don't have this plan, because actually we are like more interested in the landscape. So if you go to the CNCF, they have like something landscape CNCF. So here it's kind of like this is we have like a huge community where like we are trying like to be more aligned with this community.
Okay. Okay.
Yeah. So it's kind of like a huge community for supporting cloud native Intel domain. So like we are trying like to interact with them to like to inspire from their experience about that to support 4G and 5G cloud native environment.
Okay. Okay.
Is there any other question?
Is there more questions? Are there more questions? Sorry.
No, I think you should go ahead.
Sorry. So I can stop sharing my screen as there is no any further questions.
So hello, should I take over? This is Robert. Well, I guess so. I try to share my screen if this works. And can you see my screen? If somebody could confirm, please.
Yes, we can see it, but you don't have a presentation now.
I don't have presentation. I thought that I'm supposed in the last half an hour to present FlexRAN. If this is not the case, then I stop.
We can see it. We can see it. You can go ahead.
So I go or not?
Yes, you can continue.
So what I forgot, I mean, starting, if you put yourself back from where we were before, we were talking about the RF simulator, L2 simulator, OpenAirInterface, where you can find what and so on. And actually, I forgot one thing that I think is relatively important, which is the wiki, because actually the documentation is not super well organized in OpenAirInterface. There are some directories in the repository that we have seen before. Like I told you that for the RF simulator, the documentation is within the actually the RF simulator source. Then there is a documentation repository, but one important place for sure is the wiki. So this is what you see here. So you basically would just go to the GitLab with the code. So this is actually what we saw before, OpenAir 123 and so on. And very important is the wiki on the left side, which has especially some tutorials. I don't see it. Why don't I see it now? Here, tutorials where you have some, for example, the L2 and FAPI simulator. So this is what I showed you before. And you could just go with S1, eNodeB, and UE on same machine. So this is what I was showing you before. And it would guide you on how to set this up. And this was basically what I showed you before. So you need to make some configuration, but everything is explained in the L2 simulator would be fairly straightforward to set up. And the RF simulator, you have seen this before, is also very easy. And then there are some other things that are explained here. There are also old tutorials that might not be up to date and so on. And one thing that I wanted to bring your attention to, because it might be useful for you, is especially the T-tracer. So I showed you the scope before, and the scope is certainly useful if you want to analyze especially the physical layer signals and so on. But there's also the T-tracer, which can do similar things. And actually, so there's the eNodeB tracer that would also show you lots of information. For example, the constellation, or where is it? Here's the constellation diagram for the IQ symbols. It also shows all the logging, and it also shows time charts, for example. The red, I think, is maybe random access, things like this you could see. And if you're interested into actually checking what's going on, then the T-tracer also explains you, shows you, or can export the data via this Mac PDU to Wireshark script, and then you can actually analyze everything what is going on. So what it does is it exports the transport blocks as they are sent and received by OAI, and sends them to localhost on a specific port. You can read it up here, and then you could actually check what is going on in Wireshark. So you need to configure. There's actually lengthy explanations for NR and for LTE, and then you can see, for example, RFC connection request and set up and so on. So many of those things you wouldn't see in the RF simulator because it's no S1, so then you don't have a lot of exchange. But certainly for the L2 simulator, you could check this. Okay, this is what I kind of forgot before. So, and I thought it was important to mention this so that you would also easily find this. And there are also for some others, like how you could load. For example, what maybe some might be interested is to recording and replaying IQ samples. I think this you can probably use with RF simulator, or at least just replay and use this. Yes. And with that said, we will go on, and we will start kind of where we were before, except that now I will also use FlexRAN. And actually what I will do is I won't build it now from source. So there is the repository, and I think Navid explained it that Mosaic 5G will get open soon. So for the moment you would ask to have access for FlexRAN, but soon it should be completely open. And there is a tutorial that would explain you everything. What I will do now is just use the snaps which have probably been mentioned before. So what I will just do, or what you could even do now on your computer if you want to do, you would just type sudo snap install FlexRAN. And if you do this on an Ubuntu machine, then it will install FlexRAN for you. And then you are actually already good to go, because then you could start FlexRAN. And I don't want to get too much into the details, but there's one thing that might be useful, is to just see whether it's online. So FlexRAN, and we would check on the northbound interface, and we see that there are a lot of APIs that we could use. For example, this capabilities is here, and so where we could already see whether it's online. I will go on with L2 simulator now. Also, one thing before I forgot, so I think Navid mentioned that there was this workshop and that there's everything that you can watch. I mean, you can watch the recording of the workshop, and I explained the FlexRAN during 1 hour and 15 minutes. So here now, this will just to give you an impression. If you want to know more and see most of the features demonstrated, then go and check the video. So, and we have FlexRAN already running. This I can close for the moment, and I will just start the we'll start the L2 simulator, but also in the Snap version, because it will give us some more features that can be useful. So I will just go. I forgot to start the core network. I should do this first. No. So first the HSS, then the MME, and now the serving gateway, as we had this before. I forgot that. Now I have FlexRAN running, and I will start the eNodeB, and I will also start the UE. And again here, what we saw before, so this is the same thing that was running before with when I started from source with the LTE soft modem and the LTE UE soft modem programs. Now it's within the snaps, and actually we made some modifications. So there is also a tutorial on this that, as I said, should soon be open. But the difference now is that it does not automatically connect all of the phones. And before I go there, let me briefly show you how you can have some statistics. So FlexRAN now, before I had this capabilities dashboard, now I will look into the statistics, and the controller shows me that currently there is one base station connected, whose ID is 10,001, which doesn't use a split, only a lower level split for NFAP, which, as I explained before, is used to connecting to the UE, but it has all the other layers used. And it operates, for example, with a bandwidth, I mean, a theoretical bandwidth of 25 resource block, and also at a frequency which is not really used, but nevertheless, we have this information. So this would be where the base station would operate if there was a real SDR in a specific LTE band. And here's some information on the slicing that I want to show you in a moment. It also shows us that it's connected to the core network. So this is running on this famous Fumarola machine ending on the IP 180. And for the moment, there are no UEs connected. And this is the next thing that I will do. And by the way, since I told you for FlexRAN to install, you would type sudo snap install FlexRAN. If you wanted to just install this and follow, I forgot, you should use sudo snap install OAI-SIM. Sudo snap for those, although this might take some time, but then I guess you will have access to the record, so you could more or less easily reproduce this. So it would start, so I go again. And now what I will do is actually connect one of the UEs, just to give you an impression of what might be the, what you could then see for a UE. So there is also a help, by the way, if you would be running the snaps, so it would give you some help. For example, you could, I mean, just stop, I think, the base station. You could load some modules, and I think you could measure CPU statistics. Probably you can also have some other things. I think in the wiki there is a tutorial on the telnet, but what I added for the snap is that you can enable UEs, and then you would go with increasing numbers. So the first one will be UE0, and we will do this now. And what it does, it connects one phone. And now we have one phone connecting. So we see here periodically output that this phone with RNTI is connected with perfect channels, so the highest power headroom, the highest CQI, and the SNR on push and on PUCCH is also the best that can be there, because there's no channel that might impair any connection. But still, maybe we are interested into more statistics. So we go back into the browser, we just have a look at the statistics. So the top looks the same as I said before with these capabilities. Here we have the bandwidth, the frequency, and so on, scheduling information on the core network. But now we have this new statistic on the UE. So the RNTI looks a little bit different, because in OAI it's shown as hex. Here it's a decimal number, so this is why it's different. But if you would convert it, would come down to the same. What might be interesting maybe here now to see is the IMSI. In a commercial network, or if you would use radio, like a USRP, often you can see the IMSI, but for various reasons you might not see. So if you ever use an SDR, and you connect the phone and you don't see the IMSI in FlexRAN, then you could at least go to flight mode and leave flight mode, and then the UE will send the IMSI again, just so that you have heard this if you ever use it. Some information on the logical channel is not very interesting. Maybe what is more interesting, there are PDCP statistics. This is important when you, for example, want to see what data is flowing in and out. And actually we could now reload, and well, actually there's not that much data transmitted here, so I will come back to this. You can also see statistics on the Mac, and then I think here we will see that, for example, there are some numbers that are constantly increasing because there's always a little bit of activity. So here 4,409 is the number of the PDUs in uplink, and a bit later this is a bit more. But since there's not that much activity anyway, we don't see anything. So MAC is what transport blocks are sent, so just I mean on a very low level. IP level would then be the PDCP. Since we don't make any traffic, there is nothing changing here. So I will go back to this simulator, and I will do the same thing as before. There was this script wait interfaces. I started for one. I go to the core network, Fumerolle. I do the same iPerf as I had it before. To a single UE, we make some traffic. Now we see there is constantly 1 megabit coming and downlink. And if we now go back to the statistics, I didn't refresh yet, so we still have the old numbers. And what you might be interested to see is packet TX bytes. I think this is the correct one. So, and now we see that there were already some bytes sent, and if I load, then we constantly see new numbers. And so now you could script this, for example. I mean, let me just briefly show you. You could open curl get from this endpoint, then you just get this JSON back. You could pipe it to JQ, and then you will have something that you could use in your own scripts if you want to show data periodically and so on. And all of this is actually explained in the Mosaic workshop, so it's not very interesting. What, however, is interesting for demonstration purposes, and what I would like to show you, is the so-called drone app. Where do I have this? I don't have it anywhere here. There is, I'm not sure whether Navid told this, there is the so-called store. So this is one other project within the Mosaic 5G platform. So FlexRAN is one in the group of Mosaic 5G projects. There's also the store, and you could go and actually start the so-called drone. And I want to show you this because the drone is basically a web server that allows to open a dashboard in the browser, and then you see this network. So 80, 88, I think that's it. And so what we see here now, first of all, is a dashboard. We see that there is one base station running with ID 10,002, and this is actually 10,002. Before we had 10,001, then I restarted, so now it's 10,002. We see that it is at this frequency, maybe you remember it's the same as before, IP. You could also click here and have some more information about everything that we saw before, basically. And since this is updated periodically, we would, for example, sorry, let me go down. No, this is not, this is now shows only for the base station. If we want to see the throughput, then we either see this in this graph or this UE here. We could also click and have the statistics, and then we see that here the numbers are changing. There is some activity that's going on. This phone gets some traffic because I started constant downlink traffic. So, and this might be, first of all, interesting for your own visualization, because once you use FlexRAN, you're only one Python call away from having this web server have some overview of what is going on. And I would say it's relatively straightforward to set up. Once you already mastered starting OAI, then you will easily set this up and have an overview of your network. Of course, if you now go and you connect a second phone, let me go back here. I will go again to Telnet. I will say now I want to enable the UE1. It will connect the next UE. So now already here we see now there are two UEs, and we see also a second UE has connected. With before was MC ending on 1, now it's ending MC on 2, connected to the MME at IP address 118, which is of Fumarola, and so on. So you see your network and you can see some things. Are there some questions until here? So what I showed you now is we started from Snap the L2 simulator as before. We saw FlexRAN. We saw how we can have the statistics from FlexRAN. I started now then the drone app, which is a web server, so that if we open this in a browser, it will periodically get all the statistics from FlexRAN and then show this. So in short, we have the base station, which is controlled or which exposes data to FlexRAN on top, and then we have the browser, which gets the data through this JavaScript library, which is embedded here in this website from the controller. So this is what I showed you. So I guess there's no question then. Please don't hesitate if you have any question. And with this, I would just briefly show you FlexRAN API. Oh, now it doesn't load. Not cool. Then let me create this briefly locally, because this is, if I have this. No, I didn't install it here, sorry. So if you go to this website, which you could do yourself if you are interested, so go to mosaic5g.io/API docs with an S /FlexRAN, and then you will get a list of APIs that FlexRAN supports. And what you will find in there, for example, is just the statistics call, which if you go in the left column is completely at the bottom. You will find things like slicing, which I will now show you to conclude this little demo. You will also see other things like you can trigger, for example, handover. You could trigger exporting of information into an Elasticsearch database, which you could then use for machine learning or AI and things like this. You can also more easily just record data locally in some binary format, which then is just written to a disk, and other use cases. So if you, as I said, go to this website, you have all the use cases with how to make a call, with some examples, with a long description and so on. And one of these use cases that FlexRAN is often used for is actually slicing. And I don't want to make it too long. I will just briefly show you how you could do this. So currently there is only, well, actually there's no slice algorithm. So as you can see, I hope you can read here, there is slices, downlink, and then algorithm is none. So there is a particular scheduler now loaded, and there is no slicing algorithm, meaning in a sense there's only one slice, so all the traffic is just handled equally. And the first thing that I want to show you is now with the scheduler, the first thing that you could do is, sorry, this was correct, I just connect 2 more phones. So I will arrange them here so you can see this a little bit better. I will create some traffic to all of them. And since the channel is perfect, as I explained you in the beginning, all of them will get a stable, very good throughput. So I need to start this listening for all 4 UEs. I store again this throughput as before to 4 UEs, and they all receive 4 megabits. You can already see this here. You could also see this in the dashboard. You see all of them get very good throughput. And sorry, this is maybe important. So as I said before, we have 25 resource block. So the maximum throughput is 70.5 megabits per second. So 4 times 4 is 16, is almost full. Yeah. And what I will do now, in the next step, usually in a real system, you wouldn't have a perfect channel. So in the first lecture, I said you can use the RF simulator to model the channel exactly with the channel model. You can start just with adding some white Gaussian noise on the IQ and so on. And then I said L2 simulator doesn't really have channel models, which is true. Nevertheless, the UE is still requested to report some CQI, and normally it would measure this from the physical layer. So this is measurement on the physical layer. But what I added here for the snaps now is that they report a specific CQI. So by default, they always report CQI 15, which is the highest. And what I added is just that you can say for all UEs, just make random CQI. And then you see here that the CQI now, before it was always 15, now it's changing all the time, and you will also see this here. And the throughput is now degraded. So since the CQI is lower, the day station cannot send with a high throughput anymore, is degraded. Now, for those who are into this kind of algorithmic, who study algorithms, a few maybe you are already aware of the different schedulers. So I just want to demonstrate. In the first thing I said we have round robin. We might now load a proportional fair scheduler. Let me go to the right directly. So now I'm in the FlexRAN repository, which will soon be open under test delegation control. And actually I already have the scheduler file here, which would load a proportional fair scheduler. So I will just do this and I load this. We now see that here it switched from round robin to proportional fair. And similar to what the theory says, you see that on average, the throughput is slightly better. It might not be visible at first because before it was down relatively stable. Now it's fluctuating much more, but after some time you can see that on average it's a little bit better, which is due to the fact that proportional fair, how to say, the word is opportunistically schedules UE. So for those who know the scheduler, you schedule UEs when on average the channel is rather good through the average, then you schedule the good UEs, and if the channel is sufficiently random, then on average you will get higher throughput. Okay, this is the first thing that I wanted to say. You can reconfigure the scheduler, have different scheduling algorithms. The next thing now would be that, I start again my throughput here, is that maybe you want to say, well, there is a user group of those UEs which should be get less resources than the other group of users. So this is the realm of slicing, where you can isolate different users from each other or isolate the groups. And what I will do now, just to show you how this would work, is that you can configure slicing. So I already prepared something in here. So slicing would now happen in 2 steps. First, you would configure 2 slices. So this is what I will do here. Static slicing, this. and we see now it reconfigured this on this side. So we see now there is the static algorithm. Before it was none. There are 2 slices with ID 0 and ID 2. Both use now proportional fair, and the first uses the resource block groups 4 to 12, and the second slice uses 0 to 3. So if you want to know more about these parameters, they have the documentation on the website. And we see now all the UEs here are still in slice 0. And so in the second step, what we need to do is to actually reconfigure the slice association. So this is the second call, and this is something that I forgot to prepare. Sorry for that. So we will maybe just put the 4th UE into this slice. So and now, yes. Sorry, this is also the wrong file. Well, okay, very good. Because I don't have the documentation now. Is there another thing that I forgot? I don't have the documentation. So, but what I wanted to show, sorry for that, I'm a bit ill prepared here. You would now associate a UE to a particular slice. So you would see this, for example, in the statistics. You would also, by the way, see this here with for the UEs, and then you could put one group of UEs in one slice. The others would remain in the slice in which they are, and then you could, for example, isolate certain user groups and, for example, ensure that these 2 UEs get more traffic than the other ones. Let me phrase it like this. This is left as an exercise to the viewer. And I thank you for your attention. And if you have any question, please ask them now.
Are there questions?
Mm-hmm.
Thank you so much, Robert. You clarified many of my doubts already with them. Thank you.
Okay. So yeah, I mean, just for those who don't know what went wrong now, or I probably used the right endpoint in FlexRAN, and there was a problem with the parsing of the JSON. So usually what we would have seen now is that one of the UEs would change into the other downlink slice, and then it would be fine. By the way, I had ID 2. Maybe yes, this is the issue. Actually, this needs to go into slice 2. So, and now this UE is in slice 2, whereas the others were in slice 0. And then you could play around. So this is already relatively flexible. You can have the static algorithm. The code is relatively modular in OAI, so you could add your own scheduling algorithms. I have some code for other scheduling algorithms which were not incorporated into OAI or until now, which we will do later this year. So you could, but I mean, let's say like this, if you, for example, are working on slicing, then you could modify this, which if you search the code base, there's a file called slicing.c that you could modify and add your own slicing algorithms. You could program new schedulers and do research on that level. And using the L2 simulator, you can relatively straightforward add more UEs. So what I tested once on a powerful machine is having up to 128 UEs with this L2 simulator. So there are a lot of things that you can do. Yes. So, and otherwise, if there are no more questions, I would like to thank you for your attention, and I give back to whoever is the moderator here.